Welcome to DTH channel. In today's session, we will discuss about 8051 memory interfacing. So, in the previous session, we have discussed about 8051 and its features, right. Now, we have to little bit recollect what is memory. Then after that, we will understand how to interface the 80. Memory is a storage element which will store the informations in the form of binary bits. Okay. To store the bit informations, we are using the flip-flops. So, flip-flop is a single bit storage element which is used to store the binary informations. So, group of flip-flops are used in the memory design, or you can say group of flip-flops or call it as a register. The group of registers are in the memory. So, this is a memory which is used to store our data. So, how we are storing or how we are reading the data from the memory. So, for that the memory is a box or one container which have a number of address lines, right. So, the address lines will store a single byte. So, the byte is nothing but the data. So, for that every memory should have the address line and data lines. So, address line is used to specify the location where you want to store the data or from where you want to read the data. Okay. That is a unidirectional and also it is a group of signals. The data line is a bidirectional which is used to read the data from the memory and also you can write the data into the memory. Okay. Now, the data is available on the data line, whether it has to read or write. So, who will define the function or the direction of the data line? That will be defined by the control signals. So, the control signals which are read bar, write bar is available. Read bar what represents read operation. When the signal is low means the read operation will be performed, otherwise there is no read operation. So, when the read operation is active means it will read the data from the memory. Okay. The another one, when you want to write the data into the memory, then WR bar. The WR bar signal is low means what it represents, the controller can write the data into the memory. So, the read bar and write bar will define the direction of the data lines either inwards or the outwards. So, this is a general requirements for memory. It need the address line, it need the data lines and what type of operation, you either want to read or write. This is a single IC. So, automatically every IC should be selected by the some signals. So, CS bar. So, totally only 5 signals in each memory is available. So, the address lines is a group of signal which are unidirectional to specify the location. Then based on the number of address lines, we can define the capacity of the memory. Okay. Suppose I have a 10 address lines means 2 power 10, 2 power 10 1 kilobytes of memory. That will define the maximum capacity. How much of data you can store into the memory will be defined based on the number of address lines. Each address will hold only the 8 bits, that is the byte. Then whether you can read or write, both operations are performed means that is called it as a RAM. So, generally the memory is a two types, RAM and ROM. RAM is a random access memory, it also call it as a read write memory, which is used to perform the read operation and also for the write operation. ROM is a read only memory, only we can read the data, we cannot write it. So, that is why this kind of memory is used to derive the basic functions, drivers mostly installed in the ROM. Okay. So, here we need only one control signal which is a read bar. That read bar signal is connected in 8051 with a PSEN, which is a program store enable signal, and the 8051 memory is basically divided as data memory and program memory. The data memory is nothing but the RAM which is read and write. The second one is program memory, it also call it as a code memory because the important codes will be loaded in the memory. It is a ROM, read only memory, here only the read operation will be performed. This is a general structure of the memory. The memory is divided as data memory and program memory. Program memory is read only memory. Here whether you can select the internal capacity of 4 kilobytes or externally you can use the 64 kilobytes. So, who will define or how can it understand you are reading the data from internal or external? If you are getting from the internal, then the external access signal will be high. If the signal is high means what it represents, you are accessing the data from the internal. Okay. When the signal is low means you can get the external memory with a maximum of 64 kilobytes. So, based on your design requirement, you can get any kind of memory. That read operation is selected by using the PESEN bar. When the signal is active means, that is when the signal is low means you can get the data. The another one is data memory, which is read write memory, it also call it as a RAM. So, here the RAM internally having 128 bytes. When the EA bar signal is high means it will access only the internal RAM. Okay. When you want to increase the capacity maximum up to 64 kilobytes, then the EA bar should be low. When the EA bar is low means it represents you are accessing from the external memory. This is a read write memory. So, we have to use the both control signals, read bar and write bar signals. This is the data memory. So, which having internally 128 bytes. So, 128 bytes which represented as 00 to 7F. So, the 0 to 7F is the internal memory. Additionally, it used for the indirect addressing or for the special function registers, or maximum 64 kilobytes externally you can access it. The internal RAM, which is 128 bytes, is divided as 3 parts and used for the 3 different purposes. The first one is register bank. The register bank in 8051, 4 register banks are available, which are B0, B1, B2, B3. In each register bank, it have a group of 8 registers. Each register is a 8-bit register. Okay. So, totally 32 8-bit registers are available. That registers are accessed by using this address 00 to 1F. Then 20 to 2F, it is used for the bit addressable. That is the advantage of microcontroller, which is used as a bit and byte addressable. If you want to get the data on a single bit, in case of 8085 or any kind of microprocessor, we are outing the signal on all 8 bits. Okay. But we are taking the signal from only 1 bit, remaining powers are waste. But in microcontroller, you can access the particular bit only. Okay. That is the advantage. The microcontroller can be bit and byte addressable. Then the remaining address 30 to 7F is used for the general purpose, where the user area, the user can write or store any kind of their required applications or programs. This is the structure of the internal RAM. Okay. So, these are the 4 register banks. So, in the bank 0, we have 8 registers R0 to R7. These all are 8-bit registers. Okay. So, each register having the unique address, which are 00 represents R0, 01 represents R1, likewise 07 means R7 of bank 0. Okay. The R0 to R7 will be repeated for each bank, but in which bank you are using is depends on the bank selection. Suppose R2 means the R2 will be either in bank 0, bank 1, bank 2, bank 3 also available. These banks will be selected in the program status word. If in the program status word the bit position is 01 means it represents bank 1, then what type of register you have selected, that will be activated. Okay. Or you can directly access via the address also. Suppose if you are giving 0C means automatically it will take the R4 register of the bank 1. So, likewise first 8 address lines for bank 0, next 8 to F, 8 addresses reserved for the bank 1, then next 8 address lines 10 to 17 for bank 2, then 18 to 1F is for bank 3. So, totally 32 registers. So, 00 to 1F is reserved for the bank purpose. The next bit position is reserved for the bit addressables from 20 to 2F. So, totally 16 bits is reserved for the bit addressable, then remaining are general purposes 30 to 3F. While designing, you need to access the data from the external memory, because the RAM having only 128 bytes. Your design need more than 128 bytes, you can access from the external memory. So, during that external access, what are the specifications we have to do? So, how to interface the 8051 with the external memory? See this diagram left side which shows the microcontroller. Already we have discussed, this is a 8051 microcontroller which have number of ports, right. Then the control signal read bar, write bar, along with the two control signals which are ALE and EA bar. Okay. So, the ports, where the address lines and data lines available in the ports? Port 0 and port 2. So, that is why here we are taken only the port 0 and port 2. In port 0, the lower order and higher order address lines are multiplexed. In port 2, only the higher order address lines. Okay. So, the multiplexed address and data lines will be demultiplexed by using the ALE signal. So, ALE is the address latch enable. Okay. The AD NOT signal from the port NOT, in the port 0 we have a AD NOT to AD7. These 8 signals will be given to the latch. This is a octal latch which is the 8 inputs, right. So, this is a enable line, address latch enable. Once the latch is enable means it will generate only the address lines, otherwise it will be used as a data lines. That is why we directly given the lines as a data lines. Once the latch is enable, it will indicate the address line. Address lines are unidirectional lines. Okay. The remaining address lines based on your RAM size will be getting from port 2. The port 2 having A8 to A15, the remaining 8 address lines. Suppose you are getting A8 to A15, right. So, totally 16 address lines. So, what is the capacity of the RAM? 2 power 16, which is a 64 kilobytes. Okay. So, the maximum capacity of 64 kilobytes will be used in the RAM. So, the RAM is a read write memory. So, additionally we are using the two control signals which are write enable and output enable. Output enable is connected with the read bar signal, write enable is used with the write bar signals. So, for every memory interfacing only these kind of signals we are using. One more signal is this signal EA bar. EA bar should be a low. If it is connected to the ground, then only we can access from the external memory. If it is high means we are using only the internal memory. The another one will discuss about the program memory. The program memory is a code memory which is a row only used for the read operation. So, internally it have a 4 kilobytes of row. If it is not enough, then you can extend your memory size up to 64 kilobytes. Okay. So, either suppose if you are using both means 4 kilobytes plus 60 external memory you can access, or 64 kilobytes from the external also possible. So, whether you are using the internal or external, that will be depends on the EA bar signal. When the EA bar signal is 0 means you can use the external memory. When it is high means you have to use only the internal memory. Okay. In 8051 the internal RAM which is 4 kilobytes is available, right. So, 4 kilobytes means its maximum address is 3F, that is FFFH. So, 4 kilobytes what it represents 12 address lines. So, maximum 12 address lines are available. If you need or if you want, you can extend the memory capacity up to 64 kilobytes. So, while extending or if you want to access from the external memory, you have to activate the external enable bar. Okay. So, this diagram clearly shows how to interface the 8051 with the external memory. So, generally this is a row which having the number of address lines, right, then data lines. The data lines are bidirectional lines. We can send the data or we can read the data. Then address lines, 16 address lines we have. So, the maximum capacity is 64 kilobytes. This is a read only memory. So, only the output enable data is available. So, the output enable what it represents, we are reading the data, right. So, these are the read only memory structures. Now, we want to get the 8051 signals. So, in 8051 where the address lines? The address lines in P0 is AD0 to AD7. Okay. So, these 8 data lines are multiplexed with the address lines. So, the multiplexed address and data lines will be demultiplexed by using the ALE signal. ALE is address latch enable, which is connected to the enable of the latch. So, once the latch is enabled, it will generate only the 8 address lines, otherwise it will give the data lines. The remaining address which are A8 to A15 is available in the port 2. So, directly you can connect it A8 to A15. Okay. Then the PSEN, which is program store enable active low signal, is connected to the output enable signal. Suppose if you want to read the data, means first specify the address. Suppose I want to read the data 48 from the location 4500, means first you have to give the address 4500. So, 4500 means automatically the lower address 00 will be loaded in A0 to A7, here 45 the higher address lines. So, the address is loaded. Now, you are activating the signal, right, read bar signal. After that, the data available in the 4500. Suppose in the 4500 my data is 96, means the 96 is comes to the data line. So, now the microcontroller read the data from the memory. Okay. So, for external memory access we have to connect this data. This is another example how the 8051 is interfaced with the memory. Now, I think you have clear idea how to interface the memory with the 8051, right. So, how to interface with the RAM, how to interface with the ROM, what are the signals need for the memory. So, for interfacing the memory, you have to know how many address lines needed based on the capacity, then the data lines, then whether read only or read and write along with the chip select signals. So, based on this concept, now we will discuss about the some example. Example 1. So, interface the 8051 with 8 kilobytes of RAM and 32 kilobytes of ROM. Okay. So, here I have given the 8 kilobytes RAM. So, 8 kilobytes RAM means what it represents. From this I have to understand how many address line is required. This is a 8 kilobytes of RAM. So, RAM is only the read only memory. From that how many address line is needed for this design. So, generally kilobytes is represents 2 power 10, megabytes represents 2 power 20. So, based on that I will take it as 2 power 3 into 2 power 10, which is 2 power 13, right. 2 power 13 is a 8 kilobytes. So, here 13 address lines are required, which are denoted with A12 to A0, okay, A0 to A12. So, 13 address lines I need. So, here I have to give the structure of A0 to A13, then default data lines D0 to D7. Okay. Then this is a RAM. So, I have to connect the write enable and output enable. This is from the write bar, this is from the read bar signal. Okay. Then to activate the IC, I have to give the CS bar signal. So, these are the signals are need to design the or to interface the 8 kilobyte RAM. Okay. Now, we come to the 32 kilobytes of ROM. So, 32 kilobytes of ROM means we need address line, right, then data line which are bidirectional. This is a ROM. So, output enable only available, which are connected from the PSEN bar. So, after reading the capacity, you assume the general structure of the memory, then only you can start the interfacing with 8051. Okay. This is the structure, this is the size of 32 kilobytes. So, based on the 32 kilobytes, what is the capacity? So, K already I said it, right, K is 2 power 10, then 32 is 2 power 5, 2 power 5 is 32. So, totally 2 power 15. So, 2 power 15 it need 15 address lines which are denoted with A0 to A14, right. Address lines and data lines always started with the A0, lower address 0. So, 0 to n minus 1 14, right. So, totally 15 addresses required for the ROM and 13 addresses required for the RAM. Now, we will discuss how to interface with the 8051, right. So, this is a 8051 microcontroller, this is a 8 kilo RAM, this is a 32 kilo ROM. Okay. So, read only memory. So, now what is how many address lines required for this? 13 address lines. So, 13 address lines required for this one 15 address lines, right. How to connect? So, here 13 address lines A0 to A7, A0 to A7, right, then A8 to A13. Along with that, additional control signals are W enable and output enable. Okay. So, now here what are the signals? Port 0 and port 2. The port 0 which having the signal of AD7 to AD0. Okay. So, here multiplexed signals are available. So, we cannot directly connect with the A0 to A7. So, I have to connect with the latch. This is a octal latch. So, when this latch is enabled means it will generate only the address line A0 to A7. This one is name it as ALE signal. Okay. Then the remaining signals which are from port 2 A8 to A15 is available, right. So, A8 then 13 only 13 signals are required, I will connect. So, now the complete address lines are connected, bidirectional data lines D0 to D7 will be connected here. Okay. The additional control signals which are write bar, read bar signals. Okay. Write signal will be connected to this signal, read bar will be connected to here. So, this is the interfacing. So, for each memory it need the address lines. In a microcontroller the address lines are multiplexed, that is why passed via the latch, then connected to the memory, then the read and write control signals are connected because it is a RAM memory. The same thing we have to repeat it for the ROM D0 to D7, right. So, before that how many address line need for this memory? 15 address line. So, A0 to A7 I will get it from here after the latch, right. So, only the multiplexed signals are demultiplexed. So, the address lines are available after the latch. So, I directly taken, then from A8 to A14, A8 to A14. So, totally 15 address lines are connected to the ROM. Okay. So, now the 15 address lines are connected, then I have to connect the data lines with the D0 to D7, I will connect with the common lines. Okay. Then I need only the output enable bar. Output enable bar will be connected to the PSEN signal of 8051, which is used to activate the output signal, right. So, which is used to read the data. Whenever the signal is low means it will read the data, when the signal is high means there is no operation. Okay. So, from this we can understand how to activate or how to interface the microcontroller with the memory. One more signal is available, which is a chip select signal, CS bar. In the chip select signal, how we are generating means the unused address lines will be used to generate the CS bar signals. When A15 is via this inverter I have connected for the ROM signal. For the RAM signal only 13. So, the 14, 15 two signals are not used, right. So, the two signals I will connect it with the, here I will use it here, the 13, 14 with the one NAND gate. The NAND gate is connected to the CS bar signal. Okay. So, try to understand this. The remaining address lines here in 8 kilo RAM I have only 13 address lines. So, remaining 2 address lines which are 14, 15, right, will be used via the inverter, NAND gate and used for the CS bar signal. Here only A15 is not used. So, via the inverter I have connected to generate the CS bar. A0 to 13 address. So, A0 to A12, right. So, here 3 signals I have to use, A13, A14, A15. Okay. So, keep this in mind. Now, we have to find the address for each memory. In the RAM, what is the capacity? 8 kilobytes of RAM. Okay. Now, you have to write the address lines A0, A1, A2. So, up to A15 you have to write A6, A7, A8, A9, A10, A11, 12, A13, A14, A15. Okay. According to this 8 kilo, I have to use this address 0, 0, 0, all will be 0 up to the 12, right, 13 addresses A12 to A0. So, all values are 0, 0. So, you consider the 4 bytes A0 to A3, then A4 to A7, A8 to A11, then 12 to 15. Okay. So, only 13 address lines up to 12 I am using, right. So, fill 0, remaining are A13, A14, A15. Here we are used with the NAND gate, right, connected with the CS bar. So, when these signals here A13, A14 and A15, okay, when all signals are 1 1, then the output will be 0. So, I consider these 3 signals as 1. Now, read it the address, this one is E, then these all are 0, then 0, these all are so 0, then 0 0. So, the starting address is E000H. Then the address will be varied from 0, then 1, then 10, right. So, it become E001, then E002. Likewise, it will increase up to the maximum of all the values as 1 1. So, 13 ones you put it. Okay. The first 4 is considered as F, next 4 F, then F. Already these 3 signals is a fixed one which is used to provide the chip select signals. So, this is also F. So, the maximum address is FFH. Okay. For 8 kilo RAM, the address is varied from E00H to 4FFH. Okay. This is for RAM. In the same way, if you are finding for the 32 kilobyte ROM, so for that how many addresses we have used? 14 number of address lines, 15 is required. So, A0 to A14 we are using the address, only A15 is used for the chip select signal. Via the inverter I have connected. So, this signal will be 1, remaining is used for the memory. So, up to 0, right. First 4 0 A0 to A3, then A4 to A7, then A8 to A11, then A12, A13, A14. So, these are the 0, then these also 0 0. So, I will get it as 8000H. The same address will be increased as 8001, then up to maximum address of all ones. So, if you are putting all ones here, then it become FF, right, F, then with the A15. So, for 32 bit kilo RAM, the starting address is from 8002 to 4FFH. For 8 kilo RAM, E00H to 4FFH. I think you will get the idea how to interface the microcontroller with the memory. Okay. So, what type of memory, either RAM or ROM, how many address signals need, and what are the control signals are needed, you have to understand, then you can start the interfacing. We take one more example, how to interface the microcontroller with 64 kilobytes of RAM and 64 kilobytes of ROM. Okay. So, based on that you started to design. 64 kilobytes means automatically it represents the 16 address lanes. So, A0 to A15 you have to connect for both memory, port 0 and port 2 you have to activate to get the address signals. Okay. Summary, in today's session we have discussed how to interface the internal and external memory with 8051. So, the data memory and program memory, by activating the EA bar either 0 or 1, we can get it from internal or external. Then based on the size of the memory you have to calculate the address lines, then interface with the microcontroller. Okay, thank you.